Okay, we're ready to evaluate logarithms right now, which means that we can calculate the value of a logarithmic expression. So let's go ahead and look at a problem here. This time they haven't given us basically what is the answer on the right side. And the way I would suggest to you to do this would be to ask yourself this question, because remember that a log is an exponent. They're asking you, what is the exponent on 12 that gives you 144? So this whole phrase, what is the exponent on, can replace this idea of a log in your brain. What is the exponent on 12 that gives you 144? So in other words, 12 to the what equals 144. You're looking for that question mark. And the answer is 2. It's not 12 because 12 times 12 equals 144. It's 2 because the exponent on the 12 would be 2. All right, let's try number 2 together as well. So again, replace that log with a question. What is the exponent on 2 that gives you 32? And here's one where you're going to have to go off to the side and in your head or on your fingers count up. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that comes out to 5 2's, because 2 to the 5th power equals 32. So keep practicing with all of those exponents and figure out your powers of 2 and start to become familiar with them. All right, we've got 2 more questions. The first one is a little bit strange, so I'm going to go ahead and put up the hint here. What is the exponent on e that gives you e to the 4th? All right, but I'd like you to pause the recording and think about both of these questions, 3 and 4, and then unpause when you're ready to check your answers and your ideas. Okay, I'm writing out the question. What is the exponent on e? So they're asking you, what's the exponent that gives you e to the 4th? And they kind of told you the answer, didn't they? It's 4. Another thing I forgot to mention again is that this is one of those natural logs, so this is base e. If it helps you to write that in, you can. And I personally like to see that there because logarithms and exponential functions are inverse functions of each other. So it is true that the natural log, base e, and then this base e cancel each other out, and you're basically just left with the number 4 for an answer. So that's another way to think about that problem. Okay, and then lastly for number 4, you should have been thinking, what's the exponent on 3 that would give me 81? And you have to go off and count it up 3 times 3 a bunch of times, and it turns out that 3 to the 4th equals 81. All right, so we have finished that objective, and you're ready for question 4 with evaluating logarithmic expressions.